Good morning. I'm Ovie Kingsley Awifada, your chemistry tutor. I'm here again to teach you chemistry from the scratch so as to ensure that you understand what chemistry is all about. Well, I will enjoy you to stay tuned and follow this clip as I proceed. So chemistry is not this kind of tough or difficult subject as you may think it is. It's a very simple subject that you would fall in love with it anytime and you do better in it. So chemistry as it is as a subject, you look at this organogram of chemistry. Chemistry is centered on two major things, which is compounds and elements, or rather elements and compounds. Remember in my previous video where I recited the first 30 elements in chemistry as the requirement for anybody who wants to learn chemistry. So for you to learn chemistry, you must know what element is all about. So like I said chemistry is centered on two things, the compounds and the element as it's written here. So for the compound, you have the inorganic compounds and the organic compounds. For the inorganic compound, you have the CO2 carbon 4 oxide and the sulfur 4 oxide too. Then the organic compound, you talk about the homologous series like the alkane, the alkyne, and the alkenes. So let's come to the elements. The first element is divided into three. You have the metals. That means those elements that are solid, like the sodium Na, magnesium Mg, potassium, which is K. All these are symbols for metals, for elements. There are other elements like iron Fe. There is Al for aluminium. Yeah, like other ones like that. So we have metals as elements, we have non-metals. Non-metals in this sense, we are talking about oxygen, nitrogen, chlorine, fluorine, and the likes like that. So then metalloids, when you say metalloids, these are elements that behaves as a metal as well as non-metal. That means they have dual citizenship. Let me just call it that way, dual citizenship. They reside, they behave as a metal as also what? A non-metal. So you have aluminium, you have lead, and you have silicon. So these elements, when you put one element together with another element, that is what forms a compound. Take for instance, you are having hydrogen reacting with oxygen. You get it? It will give you what? H2O, which is water. This is a compound on its own. Likewise, you have another one like carbon, which is C plus O2. Will give you what? CO2. So element plus element give you a compound. Element plus element give you a compound. So that aside, so let's quickly move to, we are going to be talking about this in our subsequent videos, topic by topic, to ensure that we deliver what we are talking about. However, this equation here, the H plus O2 to give water, is not balanced. We are going to be talking about balancing of chemical equation in our subsequent videos for you to know how to balance the left hand side together with the right hand side, because every equation in chemistry must be balanced, and to be a good chemistry student you must know how to balance the equation. You must not be biased. Whatever belongs to Peter, you must give it to Peter, and whatever belongs to Paul, you must also give it to Paul. You must be able to balance the equation effectively and correctly in chemistry. Alright, we want to move to naming of compounds. Yes, I said naming of compounds. Just the same way naming ceremony is done for human beings, we also do naming ceremony for compounds. Compounds don't just exist. Scientists name compounds. They don't just exist. There is a union called IUPAC. The IUPAC, the meaning means IUPAC. It means International Union of Pure and Applied Chemistry. IUPAC, International Union of Pure and Applied Chemistry. This body is responsible for naming all the compounds that we have in our textbooks, that we have been used to teach. So let's quickly go now. So in naming these compounds, you will be able to solve this out based on their valency, based on their radicals. Based on their radicals. Now, imagine this compound as it is now. You have H2SO4. H2SO4. This is the compound, but we don't know the name. So we have to do some calculations now before we can tell the name of this compound based on the digits and the alphabet that we are seeing here, the element that we have put together. There are 3 elements put together to form this compound. So let's quickly do that. Hydrogen, you know that hydrogen has a valency of what? +1. Are you following? Then this sulfur, we don't know the sulfur what. So we refer to it with what? With an X. With an X value, because we don't know if we are looking for it. Then oxygen usually has a radical of -2. So we equate this now to 0. Are you getting me? The compound. So let's quickly solve it. We have these two. These two below here. For the hydrogen, you say 2 into bracket 1, which is the valency of hydrogen, plus the sulfur, which is X, we don't know. Then the oxygen has a radical of what? -2. Then multiply by the 4 that is below it. Don't forget that this 4 is attached to only oxygen and not the 2 of them. So having done this, we have 2 times 1 will give you 2, then plus X plus -8. Then the minus is powerful than the plus, so we collect our like times. You get it? Collect your like times, CLT, which is what? X will be what? You take this one to the side, you have 8. Then this one jumps and becomes 2. So X equal to what? 6. It means that the X is the what? Sulfur. The sulfur that we don't know yet. So having known the radical for sulfur, we can now name that compound as tetra. Tetra means 4 oxygen. Tetra also. It's not hydrogen, please. It is what? Tetra. Tetra oxo. Tetra means 4 oxygen. Then if it is 3, we have trioxo. If it is 2, we have dioxo, and so on. So we have tetraoxo. The sulfur that is there will be coined as sulfate. Sulfate. Then the S that we got is what? Is 6. Then we put our 6 here. 6. Then we know that this compound as it is an acid. We put acid at the end of it. So the name of this compound here is tetraoxo sulfate 6 acid. Are you getting me? Based on the calculation that we have done here, we know the radical for hydrogen, which is +1, is positive. We don't know that of sulfur, but we know that of what? Oxygen, which is -2. So we plug that in by adding everything together. We get what? S to what? 6. So from that, we name it as what? Tetraoxo sulfate 6 acid. I believe this is very clear to us. Alright, don't forget that once hydrogen is attached to a radical, it becomes an acid. The radical I'm talking about is SO4. Look at this one too, NO3, becomes an acid. But in this case of water, it is not. Water itself is neutral. That is why we consume it in our house. It's neutral, it's not an acid. But this very one, because hydrogen is attached to a radical, it is an acid. That is why the name is called tetraoxo sulfate 6 acid. I believe this is clear to us. So let's quickly go to of this compound because we've named one already. So the second one is HNO3. Like I told you earlier, hydrogen has a radical of +1. Then the nitrogen, the one usually at the middle, we don't know it. So this one, oxygen has a -2 already as radical. Are you getting me? Oxygen has -2 as radical. So let's quickly do that. We say this is equal to what? 0. The total compound equal to 0. So let's add up the whole radicals and the number that come along with it. So we say 1, which is this one already. Then 1 plus x plus -2 times this 3 below. You get it equal to the 0 that we equated it with. So we add this to what? 1 plus x minus 6 equal to 0. So by collecting our like terms together, we have x equal to 6 minus 1. So x equal to what? 5. And that x is now what? The nitrogen. So it means that nitrogen is 5. The radical of nitrogen in this compound is 5. So at this juncture, we can name this compound HNO3 as trioxo. Don't forget the previous one I said tetraoxo because it has 4 oxygen. So here you are naming it as what? Trioxo nitrate, because of this nitrogen there, nitrate. How many is in nitrogen now? 5. You do it this way, acid. So this is the name given to this compound HNO3 based on the calculation that we've just done here. So there is no other name given to this compound than this. You can also see some short name like nitric acid, but this is the name, the way the name should be. So as nitric 5 acid, this is the way the name should be based on the calculation and the recommendation of what? IUPAC. So I believe you understand this as well. So we'll move to the third compound. The third compound, which is CO2. CO2. Please, it is barbaric to write CO2 like this. It is barbaric because C is a separate element on its own. Likewise, O is also a separate element. So it must be written this way. Both of them in capital letters. So let's do that. For the carbon, we don't know the radical for the carbon, and oxygen we have -2 as usual, like I told you. So we say this compound equal to what? 0 as well. So we say x, the unknown, plus -2 times this 2. You now have what equal to 0, abi? So we now have x minus 4 equal to 0. So x here will give us what? 4. So it means that x equal to carbon. So x equal to what? Carbon. So the name of this compound is, as we have already, carbon. Carbon 4, because it's 4 we got here. Carbon 4 oxide. Carbon 4 oxide. Carbon 4 oxide. This is the name of this compound. The chemical name of this compound is carbon 4 oxide. While in biology you can call it carbon dioxide, but in this case, in chemistry it is carbon 4 oxide. That's the IUPAC name of this compound. I believe at this point you have gotten a clearer understanding of naming of compounds in chemistry. It is very, very easy to name compound in chemistry. Here I have an assignment for you. Assignment: name these compounds as listed here. The compound is, number 1 is H2CO3. H2CO3. Then number 2 is Na2CO3. Please, I believe you enjoy the teaching. So if there's any question, please comment below, and please endeavor to share this the video so that others can also benefit. Invite people to share, and God bless you. Thank you.